Welcome to the State of Developer Education, a podcast by Major League Hacking. We explore how technical leaders are creatively tackling the developer education gap to help prepare the next generation of technologists for the real world and build businesses that can adapt to any changes in the technology ecosystem. I'm your host, John Gottfried. Hi, everyone, and welcome back to the State of Developer Education. I'm John, your friendly host, and I am here this week with Byron Ruth, the Director of Developer Relations at Synadia. I'm so excited to have you here. How's it going?
I'm very happy to be here. Thank you. Yeah.
Awesome, man. Well, I always like to start with all of my guests as far back in time as many of them remember. I'd love to hear your origin story. Like, how did you first get interested in tech or programming?
Yeah, so it probably goes back to computer games. It's a pretty standard story for a lot of people, but my dad was actually in the early internet days. He would bring home computers and things like that. So we always had sort of a family computer as far as I can remember back when I was 5 or so. So that was just my sort of first introduction to computers. I had a really good childhood friend, still do, of course. His brother was actually a Linux sysadmin and sort of introduced me to the Linux ecosystem a little bit. And I was like, oh, okay, this is cool. This is curious. So we had a Windows computer at home. I got introduced to Linux from my friend's brother, and at school, all of the schools in our districts around here all had Macs. And so I sort of got a broad exposure to desktop PCs and computing and things like that early on. And I would say the first time that I learned any little bit of programming was actually in middle school, if I recall, doing Visual Basic. So I got just interested in that, playing around with that. Some of the teachers who knew those things, and it just clicked with me, and I just sort of kept fiddling around and things like that. I never thought about programming or tech as a career path per se. I actually applied to college for my two paths were actually biomedical engineering or becoming a chef, culinary arts. So I had two sort of different paths in mind. I went the biomedical engineering path. I went to Drexel University, and as part of that program, I took a few programming classes, and then I transitioned my focus area to bioinformatics, which involves a little bit more kind of computing and such, dealing with exomes, genomes, DNA structures, and things like that. And then on the side, I was asked to build little websites. Again, another common story where you're just like, just pick this up on the side. So I learned, I'm mostly self-taught, and I did a few courses in college, but the vast majority of my learning has been through self-exploration largely, and creating websites, the whole LAMP stack early on. You had that big, thick book. But a lot of it was just reading stuff online, looking at other people's code, things like that, as one does. And then I transitioned into the Python and Django ecosystem very early on, because I was like, I don't want to do this LAMP stack thing anymore. And then so that sort of like really pushed me into that whole space. And funny enough, and I'll stop talking, but funny enough, I applied for an internship at the Children's Hospital of Philadelphia. Drexel has a co-op program. So my third co-op, I applied there, and I was actually joined a team that was actually focused on education, interestingly enough. However, another person in the department saw that I had a little bit of programming skills, and he was like, how about you come work for me? And it was one of those moments where I'm like, you kind of fake it until you make it, because I wasn't very experienced, but I was eager to learn, and I was dedicated and persistent. So I just sort of used that as my jumping off point to really get into the weeds with just solving problems. And I'm not going to say I have a strong formal background in computer science or anything. I did end up going back for a master's in computer science much later, but all of it was very much about, all right, here's a problem. Let me use technology to solve the problem kind of thing.
So that's awesome. And I want to get back to the bioinformatics stuff. But before then, I'd love to hear about your thoughts on becoming a chef. Like, I love cooking too. I especially love baking. And I know a lot of people in tech where that's like a side passion of theirs. And many of them have considered getting into the business, right? Like, what about cooking do you like so much?
Oh yeah, that's a good question. So I could speak to a few of those things. So the act of opening a restaurant is completely different. I never had any interest in doing that because like 90% of them fail. Number one,
Yep.
it's a whole. I've worked in a couple of restaurants primarily as like a bus boy when I was younger in high school. But yeah, just that's a completely different thing. So largely, I learned to cook with my mother and grandmother. And I was always in the kitchen. I've always liked food and eating in general and tasting things. And I guess it was just experimenting with different cooking techniques, different seasonings. I'm much less of a baker. That's too structured for me. Funny enough, I like the situation where you have a bunch of ingredients and you just like go figure something out. Like I
Yep.
really enjoy that. I watch so many cooking shows, the Food Network, throwback to Emeril Lagasse, if people know who that is. Like early
Oh
on,
yeah.
he was super popular back in the day. I would watch his, and he was just so engaging, and it just made you want to learn this stuff and all the possibilities. So I watched cooking shows and was in the kitchen with my mom and grandmother as far as I can remember, and so it was always a uh, yeah, side passion, something that I just enjoyed doing. I only considered because again, the question of college, like what do you do? Like how can you predict what your future self is going to be? And um yeah, the funny enough, my mom was the one who said, "Hey, what about Drexel? There's this biomedical engineering thing." And I've always enjoyed life sciences. Like I'm also fascinated by that whole space. And but it's one of those things that you don't know where to go. And I was like, I know cooking pretty well. I enjoy it. So maybe that could be a career path. That's a very hard career path.
Hmm.
So I still obviously cook. I'm the primary cook in our family, and I probably like to keep it that way. Maybe in some future decades from now, maybe I'll open up a little cafe or something. But right now, I enjoy it being simply a sort of a hobby.
Yeah, that's awesome. Well, what's kind of your go-to? Like, what's your favorite dish to make?
As simple as it might sound, I make homemade pizza
Oh
dough
yeah.
and all the different toppings, and I try to make all different kinds of unique, fancy things. Whether you're rehydrating certain kinds of mushrooms and making a good sauce, it could be throwing as many veggies as you can without having it fall over and cooking them out all at the right temperature because that's really tricky to do. With
Yep.
I have this uni pizza oven.
Oh yeah, I got
It's
one of those too. It's
Yeah.
fantastic.
Yeah. Once you figure out the technique of how to actually do it without like folding your dough over and you can spin it and the timing and all that,
Mhm.
it's great. And it makes very good pizza. So yeah, I that's the one thing that I always enjoy doing. I love making tacos as well, all different
Mhm.
kinds. So fairly simple dishes in the sense, but I like to like add complexity in certain areas. I'm not into like fine dining cuisine per se or super fancy techniques or anything. I'm sure I could learn those things, but I like I like to make what my family likes to eat and just
Yep.
amplify it and try to make it interesting.
Yeah,
That's
that's really cool. I feel like there's some weird like subconscious connection between programming and cooking where it's like the creative pursuit, but there's also a technical aspect, and developers love adding complexity to things. So I don't know, but
Yep.
that's really cool. Yeah, I've considered it as a career as well at various points in my life. But you're absolutely right that like the creative part of cooking that a lot of people enjoy is so different from and disconnected from the actual business of food
Yeah.
and restaurants.
Yep.
Um, I've only ever met one person that managed to combine the two. There was a student at one of our events who got a computer science degree with like a minor in food science and ended up working for some like crazy company doing like research into like new ways of like manufacturing food. So I
Oh
don't
yeah, yeah, yeah.
know.
Interesting.
Anyway, getting back to bioinformatics. So you mentioned that the group you joined at the Children's Hospital was education focused. But what does that mean in the context of working at a hospital? Like who are they educating and about what?
Yeah, yeah. So the at the time it was, I mean, enterprises have different categories of like departments and groups. We were called the Center for Biomedical Informatics,
Hmm.
CBMI is an acronym because everyone loves acronyms in healthcare. And so that group was really focused on, and informatics is sort of a, for those in the space, a fairly overloaded term. It can
Yeah.
mean different things to different people.
What
My
does it mean to you?
so informatics is about sort of, and it makes it more concrete uh, when I talk about the particular team in that center that I was a part of, which was called the Translational Informatics Unit. So for me, informatics is really about leveraging. So if you think about like you as a patient going to a doctor, I mean, everyone has a medical record. Everyone has all of this data being collected, whether it's written down or you have scans, X-rays, CT scans, what have you. You have all your, if you're actually in the bed, you have vital sign data. If you have blood work done, everything. So it's informatics, depending on the context, really the sort of what area of the data you're focused in is really about taking that data and trying to learn something about it. And not necessarily, I mean, you hear about sort of personalized medicine as like as a thing that everyone wants, because if we don't want this generic drug that may help me, may not, you want something targeted and personalized. That's a very hard problem, not just from a data standpoint. That's obviously to make any sort of personalized medicine, that's very challenging from even a operational manufacturing or whatever, that sort of thing. So, but informatics is sort of the amount of sort of what the work we did was taking in mostly in aggregate, all the data that we have for all the patients that CHOP has seen, for example, and trying to identify patterns in that data with a particular goal in mind to say, can we find correlations between certain certain series of diagnoses or certain sort of blood test results or something like that, or certain even getting to their lifestyle, getting to where they live, and maybe there's a whole cluster of kids who have asthma. Oh, and they're all sort of near this factory that might be polluting their local area, that kind of stuff. And it's like, if you don't look at the data, and as a doctor or physician or nurse, you're looking at one patient at a time. You're not going to be able to chain together and say, oh, I've discovered this pattern organically by seeing all these patients. So informatics is like kind of taking this data in aggregate, coming up with questions, hypotheses, just like any other scientific method, but you're trying to identify a population, typically called a cohort of patients. You're trying to identify what factors, what data about those patients may be relevant, because you're also dealing with it's a whole rabbit hole to say like data privacy, but that's a thing that's a very controlled. You can't just say, hey, I'm a doctor, so I can see everyone's data just by default. That's not a thing. So you have to be very deliberate about, this is my question. These are the factors, the dimensions of this patient population that I want to, let's say, get from the health record or from other databases that exist. And then these are going to be my methods that I'm going to apply given this data to be able to ask these questions and analyze it and whatnot. So you have, so for those who don't know, Children's Hospital of Philadelphia is actually split. There's obviously the hospital side, but then there's a whole research institute. It's a giant research institute, and it's one of the biggest in the country. And so you have these physicians and nurses and all of these healthcare professionals who have dual roles of being both in the clinic and researchers. And so largely what our team did, and what the center that evolved into a full-blown department at some point, we were facilitating that informatics sort of workflow, for lack of a better term. We provided access to data that they asked for, because they're not the experts of how to query a database or get data. So we needed a whole team of people to help facilitate pediatric research, informatics to generalize. And so this involved sort of making data accessible. This included at a certain size and scale of data, Excel doesn't work anymore. So how can we build tools for researchers to work with this data at a certain scale? How can we educate people of new methods that might be relevant to the questions that they're asking of the data? Things of that nature. So we sort of were these brokers of data, these sort of honest brokers of data, because we're not directly involved in the research. We weren't going to be like on the papers per se, the journal articles or anything like that, but we were facilitating the research work and trying to get these people up to speed with like modern tools, really good computing environments and things like that. So that was largely sort of the overarching goal of our group.
Interesting. So the education component of it was almost like best practices for research education, right? Like it sounds like people would come to you with a, project that they were working on, and you would facilitate the research that they were already doing.
Yeah, largely. Like we were not the domain experts per se. Like, I mean, if someone is trying to understand, is an expert in sepsis, I'm not going to tell them what questions they should ask, but there's always that disconnect of saying, I have this question, how do I make it happen? How do I execute on it? Yeah. And you get a spectrum of people depending on their skill set and their background. We have plenty of researchers who have brilliant ideas, but their tool that they're most comfortable with is Excel, and they can't actually follow through and execute on the question, because that's not going to be sufficient for that kind of question or the scale of data that they're working with. Mm-hmm. So it's really just trying to listen to the researcher's needs and saying, okay, we can give you access to data. We can try to provide these set of tools that make the most sense given your needs, and then educate you up to the point that you can be a little bit more self-sustaining, self-service. Mm-hmm. And then the other piece to it too, which the sort of informatics education team, which is a smaller team, they would bring in like external people as well to just educate, like say, this is the latest research, this is the methods that I applied, this kind of stuff. So mm-hmm. it was a really good group, both super technical as well as really trying to just get these researchers up to speed with modern methods, modern tools, or connect the dots between, oh, I read this research paper, I'm going to re-implement this, but on our data. Mm-hmm. How do I do that? Because famously, most biomedical research papers are terrible in terms of reproducibility. Like you can explain your methods all day long, but most of the details are left out. And so there's been, as a quick tangent, there's been a huge amount of effort by the NIH and other grant funders who are saying, you need to publish your source code or your methods or your notebooks or whatever techniques that you used. And you actually have to include that, ideally even along with the data, if it's allowed, if it's de-identified data. So they're making that more of a mandate because the reproducibility of biomedical research is so bad. And so one of our sort of efforts here as a group, as a set of technologists who really love reproducibility with like Git, and we like in software, we know how to do that quite well. Yeah. We at least have techniques and know how to do it. And so we were trying to also encourage and teach people, the researchers, to say, how about you adopt these methods, these techniques in your context? it's really hard to teach someone Git who's not working in it all day or anything like that. So again, it's figuring out like what's the right balance, what's the minimum thing that we can teach them so that they can trend in that direction of improve reproducibility, because it's going to make it easier for them when they submit their paper, submit the results, because they're going to have to do that eventually anyway. So there's a lot of that kind of education as well. It's trying to bridge that gap of like, all right, there's really good stuff in technology that we've learned and been doing for years. Let's bring that over to this informatics side of things, and try to improve how everything is working.
So when you're thinking about like reproducibility in that space, like how much of it is context dependent, right? Like you use the example of, a bunch of kids live near a factory and they suddenly all have asthma. Like I would imagine that the stuff that people are trying to reproduce is a little bit more generalized, right? Like, tens of thousands of people have this symptom and they all have this link between them. Like, am I going in the right direction there? Like,
yeah, no, I get what you're saying. So it's more about, so given the slice of data, again, at, let's say at CHOP for our kids, our cohort, given that data set, and given, let's say, the code that I used to take that data set and derive some statistical output.
Yep.
If I'm a researcher in another institution and say that paper's published, if I pick up your paper and you're like, all right, these are the factors that I use in my data set at my institution, and here's the code. Not to say that they will get the same results because they're in a different place. They have a different cohort and different population. But if they were able to recreate the end-to-end, say, I can model my data set identically to what the paper said. I can apply the same, if I have access to the code, those are the same exact functions that you use and statistical methods that you use. So you're going to have a different input because it's a different data set from a different institution, but the code in theory should work, assuming that the input data structure or data model is the same. So it's more about, because it's always a trust thing. It's like you publish results and you're like, well, I guess I'm just going to take your word for it. I mean, it's peer reviewed. So that's where the trust comes in. These are peer reviewed things, but even the people peer reviewing, they're going based on their experience in their gut. They don't have access to the data or the code. So it's the same. It's the same thing. It's like you, I draw an analogy to saying, okay, should I trust this black box software that's installed in my computer, or can I go look at the source code and I can validate for myself, kind of thing.
Yeah. I mean, it's so interesting because with data, right, and especially when we get into the topic of like machine learning or AI, there's been a lot of discussion recently around reproducibility and what is the data set and how is it trained and all of those different things. And like, obviously, medical research has its own sort of quality control mechanisms that don't necessarily exist in consumer tech, but like, I can't help but feel like there's some existential similarities to how people are thinking about, some of these new advances.
Absolutely. I mean, you can think of it like, so there can be, I mean, some research outputs aren't necessarily just like, all right, I made this conclusion, cool, there's a correlation here. A lot of the basis of research results are going to go into new clinical practices. So this is the foundation of things going forward, and adaptation of clinical practices, which is going to impact the patient at the end of the day. So if we're all on a house of cards, that all of this stuff is, I'm not saying we are, but if we can't trust the research results and they're inaccurate, they're wrong, and we're using that information to drive clinical practice at the end of the day, because it's a loop. Like, we're not doing research just because we're doing research for the sake of it. You're using it to learn and how to apply it back in the clinic. This is what this whole translational aspect is. You do the research and it feeds back, it translates over back into clinical care. And so it's one of those things similar to, I think the whole AI concern is very much related, like you said, because AI is pervading all aspects of our lives nowadays. It's in everything, and there's biases, and there's all sorts. And it's like, if it was just in a research lab that didn't touch the normal general population, nobody cares, because that has been true since the 60s or whenever it sort of came to be. But now, because it's all over the place and all of our day-to-day applications and smart TVs and all this kind of stuff, it's a whole different ball game now. So I think it's the same thing. It's like, if you can't explain how this AI model came to this conclusion, how can you trust it? Like, it's there's obviously plenty of stories of terrible biases that have occurred. Yeah, so I think the more it touches general population, the more it sort of invades your privacy, your life, no matter if you're a patient or just a regular person. Yeah, people are going to ask questions. Explain this to me. Why did this happen? So
Hopefully they would, right? Like, people may
yeah.
not, but I know this is not really your space anymore, but do you think that, bioinformatics or medical research or even clinical care are going the direction of computer-led outcomes, right? Because I think, like, okay, if I type something into Chat GPT, it's going to give me a particularly opinionated result that may or may not be correct, right?
Yeah.
And perhaps it's improving over time, but like, there's not necessarily a human interface there to tell it if it's right or wrong. With
Mhm.
doctors, you have that human at the other end, but like, what's that balance, right? Like, what direction is it moving in?
Yeah, no, that's a great question. So this has always been a very contentious topic. So we had a handful of researchers who were also big into building machine learning models and things like that, because you can still get interesting results and you can still do very good inference using sort of modern techniques like this. But sort of the conclusion I would the simple conclusion is that we always framed it as human in the loop. We always framed it as like, all right, these things can make decisions, they can make suggestions, but it's always going to be a doctor or an actual practitioner who's going to make the final call and validate. So it's one of those things, to your point, with even Chat GPT, I can never pronounce that. It's the same thing. It's like, this can spit out some stuff. I can ask a question, and if I'm happen to be an expert in that domain of the question that I ask, I can quickly read through it and validate that if it's accurate or not. And so it's a similar thing. Like, it can still do the work for me, or GitHub Copilot, or any of these things that are like generating stuff. Great, you can generate stuff. It prevents me from needing to type all of it out, but I can still quickly validate if it looks good and if it makes sense. So in the context of healthcare, I think using these various models, and explainable models are critical. However, the fact that a human is in the loop to validate sort of any inference that occurs by any of these models, you still at least have an expert opinion on top of that. And so that's where you can get this nice balance that, no, an AI is never going to replace a doctor in total. It can augment a healthcare professional to do their job and to reduce the amount of time, possibly. And in certain contexts, for example, like imaging, you can have an AI that can detect certain spots in radiology scans that there's still human error, just like anything else. So having that as an assistant, essentially, to catch things, to flag things, and then the radiologist can basically validate or not. So it's really more of an augmentation rather than any kind of replacement. That's sort of what I've seen. Yeah.
That's comforting, I suppose, to a degree. So you worked in that space for a long time, and now you've kind of made this transition into what I would call, like, traditional tech, right? Like, you're working at a tech company now, not a hospital or a research
Yeah.
institution. I'd certainly love to hear about what you're working on there, but I'm curious, like just from like a starting perspective, it's rare that someone comes into tech with a hard science or research background. Um, has that changed at all how you interact with the actual like work of a startup?
Yeah. So that transition was necessary. It was hard for me to make that decision, but I'm very glad I did, because it was one of those things. So yeah, for context, I was at CHOP for 14 years. It was my entirety of my professional career after college. So that's all I knew. I loved it. I loved my team. I loved my boss, who was my boss for the entirety of that time as well. And so yeah, so I led a couple engineering. By the time I left, I was a director of engineering. I led a couple teams, and sort of one of the things that I did while there and transitioned from was being a individual contributor. Largely, I would still write code even to the day I left, but it was more about I really enjoyed sort of educating other developers, people new to the team. I really enjoyed talking to the researchers and I would try to act as like a translator effectively, between, all right, this is a researcher, they have their jargon, their lingo, their mental model of what technology can do for them. Sometimes that's inaccurate, or there's some shortcomings or short-sightedness there. And so we would talk with them. I would talk with them and be like, hey, this is what is actually potentially possible depending on what you need. Sort of the premier thing that we had built before I left was this, using all the fancy things like cloud and Kubernetes and all of those things. But what we tried to build was essentially this research platform, for lack of a better term, which allowed us to create these isolated environments for research teams on a per project basis, where there was a web interface that people could log into. We would deliver identified or de-identified data depending on their needs for their research project, and a fresh like set of tools. So your Jupyter Notebook, your RStudio, your terminal, all the things that sort of are comfortable for these types of researchers. And we'd create these fresh environments that we could spin up and spin down very quickly. And again, on the air of reproducibility and convenience and consistency and all these kinds of things, if they came to our platform, they knew that they're going to get the same looking thing, same feel of pristine environment, essentially, for every research project. And they're not going to have to manage data on their shared file system among their team, or they don't have to like download all these dependencies locally on their computer. They can do all the compute and all the data stuff in the cloud, that in an environment that we sort of built for them. And we got to that point of being able to spin up these environments. And we had, when I left, probably a couple of hundred active research projects, all with distinct environments. So that was like, so a lot of during that whole thing about like talking and educating and meeting people where they're at, because that's the other thing. Again, not everyone knows these tools and all this fun software that you could use. So a lot of it had to sort of boil down to saying, all right, let's understand where people are at, where these researchers are at in terms of their comfort level with these tools, educating them, trying to adapt this environment to better suit their comfort level, their needs. We had a dedicated education team in this larger program who my teams would interact with them very much to create video content, guides, things like that, to sort of how to navigate this environment and use it effectively. So that was like sort of my main focus area, largely for 6 months to a year prior to leaving. But yeah, I've always interacted with a lot of people. I've always enjoyed teaching in various levels. But so with the transition, I saw it as an opportunity to get into a role that was even more focused in being that bridge between end users or customers in the context of Synadia and all of the cool technology that we have to offer. And I personally saw a gap in, so again, for listeners, the context of Synadia, the founder, Derek Collison, founded the company in 2017. He created this open source project called NATS in 2011. That was the first open source release. And so it's been a very popular open source project for many years, very heavily adopted. And after he founded the company, he wanted to essentially focus on building products on top of this open source thing. I was an open source user of NATS for 6 or 7 years. So I was already sort of involved in the community and using it and things like that. And over time, as I got more involved, I saw personally a gap in sort of getting up to speed with NATS or seeing questions in the Slack channel and like new users and things like that. Like, where do I find this information? How do I do this? And that's where I started observing like, oh, okay, there's a gap here, not to anyone's fault, but I think there was not really like a clear owner of, let's say, the NATS documentation over the years as it evolved as a project. So as I got more involved in that community, I started creating content for that community because it was something to write about. And I personally tried to like get in the habit of writing more. So I started a newsletter, the NATS newsletter, NATS Weekly. And I also started this website called NATS by Example, which was really to focus on the worst thing about examples in documentation or on Stack Overflow or whatever is that you copy and paste them, or maybe you do, and they never work because you don't have certain dependencies installed, or like they're outdated or something. So this site was not only to bridge a gap of really good curated examples to showcase certain features of NATS, but it's all built on a whole CI workflow and a true GitHub repo with using Docker containers that actually set up your entire environment and all the dependencies automatically. And so there's a whole CLI tool and stuff. So I really wanted, again, reproducibility, going back to that theme. Let's create a set of examples that a person can literally clone the repo, install a CLI, and just run one command and target any example that exists in that repo. And all of the Docker containers will build and spin up, and they can tweak the code. You run it again, it'll rebuild everything, and they can see the changes in their output. So it was really just trying to create that environment for people to learn quickly and in a reliable way without them having to necessarily know how to set up everything properly ahead of time.
I have so many questions about NATS by Example. Like when I was looking at it, it's kind of like, it's kind of simple. Like the way you present it is actually very straightforward, but under the hood, there's so much going on. And one of the things that like really struck me about it is like the general like information hierarchy of the examples is very intentional. Like, and we can include some kind of screenshot in the show notes or something, but when I was like reading through some of the examples, it's like, okay, you have a summary of what you're trying to achieve. You have language filters, but the actual like side by side of almost the explanation and the code itself felt really unique to me. Like I haven't really seen things presented in such a like easy to understand way. Like I've written tutorials, you know, and often it's a blog post or something where it's like you scroll through and there's code snippets and like maybe some comments, and it's trying to achieve a similar thing, but like it seems like you put a lot of thought into how you presented this, right? Like where did that come from?
So the format's not super, I wouldn't say novel at all. So like
you say that, but like you look at most documentation and it's much harder to understand.
It is. I meant sort of the layout. So like there's a gobyexample.com. There's other sites that are, I think there's like Tailwind, I think maybe has one. There's a bunch of like byexample.com variations those are I personally just like when I want to learn something and there's like a discrete topic, I just click into it. And for me, it was, and again, for those who haven't looked at it yet, it's a code file. It's a single, generally every example is a single main.go file or a main.sh if you're using the CLI or .py or whatever. And when you create these examples, you're writing comments. And I have a build process that actually extracts all the comments out and renders a web page. And so I wanted it to be in line and sort of like together, because and then people can even just go to the source code and read it right there if they prefer that format. But like there's that presentation on the web, which is sort of like one angle that I was like, and trust me, I'm not a designer. There's many, many improvements that can be made for the website, but this was sort of like the starting point. But it was like, okay, we have the web, we can present it in a nicer way that's maybe more readable. And so I just focused on sort of a build process that would take the raw source code, split it out, generate HTML at the end of the day, formatting nice, all that kind of stuff, syntax highlighting, and hopefully fairly straightforward navigation. And so, but the repository is literally just a set of directories that are nested following the sort of URL hierarchy. And then there's a build process behind the scenes. So I guess it was just sort of like, if I'm coming to an example and I want to know that it works. And the other sort of unique thing with that web page, which I personally have not seen on other sites, the closest thing you could probably see is for sites that are showcasing JavaScript examples, because you have the benefit of a runtime in your browser. So you can show, here's a little snippet of code, here's the corresponding output. But if you're using any server side, anything or non-JavaScript runtime, you need to explicitly generate that output. And so as part of that build process, what I do, and this also confirms that the example works, because I wouldn't be able to generate the output if it didn't. It actually executes the output. It captures the output using ASCII Cinema. And there's another section on every examples page that shows the actual output of the code that actually executed. So you sort of have the mental model of like, all right, I'm reading through this. I can see sort of as a developer, I'm writing, this is what I'm writing, but what is my expected output if I'm actually like seeing sort of consumption of messages or like stream information or whatever. So what's the output? And so right below that shows this is the output that actually executed. So you can sort of like tie those things together. And I have other crazy ideas of actually trying to inline the output right alongside the code examples too. So getting smart about like, all right, if you're printing something, logging something, whatever, I can actually know the line number and correspond it to the actual output line and try to get it in line so it's a little bit more readable. And this is actually probably more similar to things like Brett Victor has done with blanking on the names, but there's a lot of really cool like interactive interfaces where you can like change things at runtime and you can see the output as you're changing stuff. So I definitely have some fun, cool ideas around that, but that was sort of a starting point, and it has certainly filled a need for a lot of people coming to Nats. I largely point people to that if they're looking for just like, all right, let me learn these concepts. And much of this work is certainly going to be feeding back into the Nats documentation proper. That's a large portion of my role, is to sort of reorganize, restructure, improve all of the docs now that I have joined.
Yeah. The generator, did you build that from scratch?
Yep.
Have you thought about abstracting it away as like maybe it is abstracted away as like a general docs generator? Because I've seen like there are docs generators out there, but I haven't seen one quite like this.
It is actually generic. Yeah. I mean, you can write any examples. It doesn't matter. So
What's it called?
So it's just part of the same repo. So the Nats by example repo, there's a command line tool that includes the actual build and generation components. But
So if
yeah,
someone ripped out all of your Docker containers from that and plugged in like a bunch of React examples, it would generate the same thing.
yeah, because it inspects the source code. And so it says you're a .js file, .ts file. It's just going to pull all the comments out, render everything the same way. And sort of the overarching template, like the theming of Nats by example, that's just a Go template at the end of the day, which you can swap out. But the main crux that gets generated is just the sort of 2-column layout that that you actually see there. So yeah, it definitely could be reused for other doc sites for sure. And I've decoupled the output generation and all that kind of stuff. So yeah, it certainly was one of those things where I was like, this could be generally useful. Maybe like if it was generalized in terms of like a project named a standalone thing, it's like, hey, you can generate these docs and execute your output and all that kind of stuff. Yeah, I have there's a command that you can actually eject the example into a standalone like zip folder. And I have another idea that I'm going to be exploring is actually having a click button to deploy to code spaces or Gitpod to be able to have a live runnable environment for people to get started. So there's a lot of potential example ideas there.
Yeah. I feel like it has a lot of potential. Like I've spoken to so many people who a core part of their role is creating documentation and, you know, general developer education resources. And there's a lot of like struggles with tooling, right? And the thing that I thought was really kind of novel here is that like one of the biggest struggles with tooling is keeping everything up to date and in sync, right?
Yeah.
And if you are generating it from an actual running example of the code, you don't really need to worry about that, right? Because you just regenerate it and it has the latest version and you don't need to like go line by line trying to update it, which frankly is what a lot of people do right now.
Yeah. Yep. Yeah. There's a lot of inspiration too from like people still like documentation with like inline snippets, and that's fine. And so that's going to be another area where as part of a build process, as part of a very similar to if you've ever copied and pasted like a snippet of like GitHub code or code on GitHub, or like SourceGraph has a feature that's very similar where you can sort of like render an inline code block that is derived from an actual full-blown source file.
Yep.
But you can extract out that piece, put it in a different context because you want a full-blown blog post or documentation page. And maybe this format of Nats by example isn't, and this goes back to like, what is your audience? Like, who's your audience? What are they trying to accomplish at the end of the day?
Mm-hmm.
It's not going to satisfy everyone's needs, depending on how they're kind of approaching and wanting to learn. However, the code never changes at the end of the day. I mean, the context and the information around it, the wording, the framing of it can change, but code is code. If you're showcasing an API or showcasing this is what you need to do, you can have a bunch of different kinds of text around that to kind of introduce that thing, but you still want a stable reference example that and work runnable code that you can still rely on. You don't want to have to be in your documentation recreating the same snippet all over the place and having that fear that it's eventually, because it always will, eventually getting out of date. If you have a source of truth set of examples that you can consistently always rebuild, you can simply bump, like, let's say the version of the Go library or the NAT server, you bump the version, you rerun the CI, and you just validate that everything still works as you expect. You're done. It's very easy to keep up to date and maintain. So this is sort of going to be a very core foundation for the sort of the revamp of the docs and how we don't get things stale and out of date.
Yeah.
So,
well, I'm really excited to see where it goes. Like, honestly, I think it's a pretty novel approach to docs. We're nearing the end here. I really appreciate everything you shared. Like, it's such a fascinating space that you've been involved with for so long, and the way that you're thinking about this world of, you know, creating really good docs. Like, I think it may be more novel than you're giving yourself credit for, but it's really, really cool stuff. The question I always like to end on, which is kind of a softball, but I find it interesting, is if there was anyone in the world of tech or DevRel that you could just like aspirationally take to lunch and pick their brain for a couple hours, like who might it be?
Yeah, it's a tough one. There's a lot of names. I will try to stay in the context of DevRel, just because. But I mean, we know like Joe Armstrong has passed away, but like he would probably be up there with one of because he was just a brilliant guy. And I love all of the people that are really experienced in our very short history of an industry in computer science. That the fact that a lot of the original people who laid this foundation for all of us many of them are still alive, which is amazing. But anyway, in the context of DevRel, I would say Tim Berglund, who was at DataStax, he was at Confluent, and he's now at Startree.
Yep.
He is just I just always have appreciated his talks, how he would introduce concepts, his learning materials in regardless of what company he's been at. He's a very captivating speaker. And I think when I was sort of like learning how to create content or like learning how to like articulate things, I would always want to watch, no matter what topic he was talking about. I just always gravitated to watching his, and I watch a lot of talks, YouTube videos, things like that, of a variety of people. And he's always just been a very captivating person in the DevRel space. So that would probably be the one person. And then Gregor Hope is probably another person who I very early on learned about his enterprise integration patterns book, which is seminal work in my opinion. And he also is an incredible speaker and writer. He can just connect. He just brings a really great mental model in any topic that he talks about as well. So he's another person who I can listen to either of them all day long. Even if they're repeating the same conference talk in two different places, I'll probably listen to it because they tend to frame things a little bit differently. And so I would say two of them, and probably just to finalize Jessica Kerr or Kerr. She's another really awesome person, and also a great speaker, and really enjoying a lot of her content on systems thinking. So
awesome. Yeah, I had Tim as a guest recently, and he was
awesome,
super interesting.
Very animated.
Awesome, man. Well, thank you so much, Byron. I really enjoyed everything you shared here, and I hope everyone listening enjoyed it as well. It was definitely a new area for us to explore here. If everyone liked the podcast, definitely like it and subscribe and share it around. We'll be publishing more episodes soon. But thanks again, and happy hacking.
Yeah, thank you so much. This was really fun.
The State of Developer Education is brought to you by Major League Hacking, or MLH. To find out more about MLH and how we power innovation, cultivate developer communities, and teach technical skills to students around the world, visit mlh.io. And then make sure to search for Developer Education in Apple Podcasts, Spotify, Google Podcasts, or anywhere else podcasts are found. Make sure to click subscribe so you don't miss any future episodes. Don't forget to like and review the show, and we'll give you a shout out on a future episode. On behalf of the team here at MLH, thanks for listening and helping us empower the next generation of technologists. Happy hacking.